What is AI and how does it work? Artificial intelligence, AI, has rapidly transformed from a concept of science fiction into a tangible force reshaping our world. From recommending movies on streaming platforms to powering self-driving cars, AI's presence is becoming increasingly ubiquitous. But what exactly is AI, and how does this seemingly magical technology function? At its core, AI refers to the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. This essay will delve into the fundamentals of AI, focusing on its primary subsets, machine learning and deep learning, and illustrate different types of AI through analogies and real-world examples, making these complex concepts accessible. The foundational idea behind AI is to enable machines to perform tasks that typically require human intelligence. This encompasses a wide range of abilities, including problem-solving, understanding language, recognizing patterns, and making decisions. The journey of AI often begins with machine learning, ML, a subset of AI that allows systems to learn from data without being explicitly programmed. Imagine teaching a child to recognize a cat. You wouldn't give them a precise set of rules like it has 4 legs, fur, a tail, and whiskers, therefore it's a cat. Instead, you'd show them many pictures of cats and non-cats, and over time, they would learn to identify a cat on their own. Similarly, in machine learning, algorithms are fed vast amounts of data, enabling them to identify patterns, make predictions, or take actions based on what they've learned. For instance, a spam filter learns to identify junk mail by analyzing countless emails labeled as spam or not spam, gradually recognizing common characteristics of spam. Building upon machine learning is deep learning, DL, a more advanced subset inspired by the structure and function of the human brain's neural networks. Deep learning models, known as artificial neural networks, consist of multiple layers of interconnected neurons that process information hierarchically. Each layer extracts increasingly complex features from the input data. Think of it like a detective solving a case. The first layer might identify basic clues like colors and shapes. The next layer combines these to recognize objects like faces or cars. Subsequent layers then interpret these objects in context to understand the overall scene or situation. This multi-layered approach allows deep learning to handle incredibly complex data, such as images, speech, and natural language, with remarkable accuracy. For example, facial recognition software uses deep learning to process pixel data through many layers, identifying subtle features that distinguish one face from another. AI systems learn and operate through various paradigms, broadly categorized into 3 main types. Supervised learning. This is the most common type of machine learning. In supervised learning, the algorithm is trained on a labeled dataset, meaning each piece of input data is paired with the correct output. It's like a student learning with a teacher who provides correct answers for every problem. The algorithm learns to map inputs to outputs by finding patterns in the labeled data. A real-world example is predicting housing prices based on features like size, location, and number of bedrooms, where the algorithm is trained on historical data of houses with known prices. Unsupervised learning. Unlike supervised learning, unsupervised learning deals with unlabeled data. Here, the algorithm is tasked with finding hidden patterns or structures within the data on its own, without any prior knowledge of the correct output. It's like giving a child a box of mixed toys and asking them to sort them into groups without telling them what the groups should be. The child might sort them by color, size, or type. In AI, unsupervised learning is used for tasks like customer segmentation, where an algorithm groups customers with similar purchasing behaviors, or anomaly detection, identifying unusual patterns that might indicate fraud. Reinforcement learning. This type of AI involves an agent learning to make decisions by performing actions in an environment to maximize a cumulative reward. It's akin to training a pet using treats and praise for desired behaviors. The agent learns through trial and error, receiving positive rewards for good actions and penalties for bad ones. A classic example is an AI learning to play chess or Go, where it makes moves, receives feedback, winning or losing, and adjusts its strategy over countless games to improve its performance. Self-driving cars also utilize reinforcement learning to navigate complex traffic scenarios, learning optimal driving behaviors through simulated or real-world interactions. In conclusion, artificial intelligence is a rapidly evolving field built upon the powerful foundations of machine learning and deep learning. By enabling machines to learn from data, recognize intricate patterns, and make intelligent decisions, AI is transforming industries and aspects of daily life. Whether through the guided learning of supervised models, the pattern discovery of unsupervised algorithms, or the trial and error optimization of reinforcement learning, AI continues to push the boundaries of what machines can achieve, promising an even more integrated and intelligent future.